31 times. Facebook has been asking this question for 31 times. And I have to say this is one of the most confusing questions I have ever seen. Suppose we are given the array like this. The first element indicates it's node 1. The second element indicates it's node 2. So they're referring to the node dot value. Each subarray indicates the neighbors of the current node. So the 2 and 4 indicates that the first node links to the node 2 and node 4. This is undirected graph, but that actually means we have 2 directed links. So the first node points to 2 and 4, the second node points to 1 and 3, the third node points to 2 and 4, and etc. So we have the following graph. And the question is asking to come up with a deep copy of the whole graph. That means each node, they have to have different addresses, but they have to indicate the same value. There are 2 attributes in the class node. So in order to create a new node object, we can call in the constructor by pulling the parameter node.value and an empty array just to initialize the node object. I'm going to talk about the DFS approach. Let's start with a very simple example that we have the array 2 and 1. So that means the first element links to the node 2 and the second element links to the node 1. Apparently this is an infinity loop. In order to perform the DFS, we need to have a base case. We can have a visited variable to store the historical node that we reach to. At the first node, we scan its neighbor so we can find it links to 2. So we go to the second node and we mark the first node in our visit variable. At the node 2, we scan its neighbor so we know that it's going back to 1. At this point, we need to check if 1 is already exists in the visited. Now I'm going to use the blue color to indicate the original, and the purple color indicates the deep copy. Every time we visit the current node, in the visit variable, we can come up with a mapping that the original one is actually mapping to the deep copy of itself. Initially, we can just create the deep copy object without the neighbors. So that means we have this individual node without linking to other nodes. From the DFS recursion, at first, we're on the first node, and we create a deep copy at node 1. As we're doing the recursion, we go to the node 1's neighbor. And then we're reaching to node 2, and we create a node copy of node 2. And because this is a loop, we are back to node 1. They actually reach to our base case, and because we already stored the node 1 in our visited variable, and we know it's mapping to the new copy of node 1. As we're returning from base case to node 2, we know it's time to make the link. So now we link the node 2 to node 1. And because this is recursion, we know eventually we'll go back to node 1, and it's time that we make the link from 1 to 2. And I have the Python code here. So if we're reaching to the base case, that means the node 1 is in the self.visited. That means, so we are returning the deep copy of node 1. And after the returning, the node 1, the deep copy of node 1 will appear here. So we can link to 1. As we are finishing up the last recursion, now we are on the deep copy of node 1. So that means node 1 links to node 2. And this is the Python code. In order to have the local variable visited to store the variable outside of the recursion, we need to declare the self dot in Python. And these 2 if statements are the base cases. And each time we need to mark the visited node, just like what we did. And the for loop that will recursively going through all the neighbor in the neighbors. If you like this channel, please click like and subscribe. Thank you.